Here's something for you Land Rover guys to have a chuckle at. This is a non-Land Rover, and you can see that the vehicle has had 6 of its wheel studs snapped. It's been modified to take extra weight. You can see the airbag assembly on here, and the thing actually can't cope with the weight that has been added to it. Vehicles will have wheel studs to denote how much weight they can carry. Now, this one here, you know the badge, you'll probably know which vehicle it is by the front grille. It's now we're getting problems with these because of the equipment that's been put on the back. It's right on its limit, so you can see it's having issues. I've just done a clutch on one of these, which on a 17 plate, which shredded it. Some of it's down to driver abuse. However, the weight of this platform on here is nothing like the Land Rover at all. It's a pity that the demise of the Defender has come. Anyway, some people will put down the Defender, but it certainly did do a job, and it was reliable for many years. So anyway, right, we'll get into electrics, and the first thing I want to do is get a scanner out. We're not starting at the dire basics. We're going to jump about here. Because I want you to see more about how you can utilize different equipment for your own aims. Right, so I've gone into the data portion of this scanner, which is reading what the ECU can see and what it's implementing. Okay, now this is on a Puma 2.2 diesel. That's an EU5 DT244. Anyway, you can scroll through and you can get an idea of what the ECU is seeing in the way of voltages from inputs from sensors. Oh, look, there's one, the Saudi overspeed. Now, that's quite interesting. I don't know what that actually means. Anyway, right, what I'm looking for is the control module power supply voltage, which I've got here, okay? Now, what this is doing is reading the battery voltage until I start, okay? You can see how it's graphed, and you've also got figures there, and I know that the vehicle's actually, the alternator's working, okay? But by the graph, and this is what I want to show you, you can see by voltage over time what's happening. This is the same with an oscilloscope, and this is one thing that when I saw it, I went on a training course and I saw the oscilloscope and I thought, I've got to use that. Now you can see from flatline 0 and then you start the engine, it goes up to 12 volts. Now you can actually see the voltage over time. And for me, being a visual person, it makes more sense. It does for quite a lot of people. It's actually easier to use an oscilloscope than a multimeter in most cases, okay? You can see what's going on. Whereas with multimeters, they have their uses. I'm not saying that they're bad because they have their uses. You are basically looking at numerical figures, and that is it, okay? So with an oscilloscope, and I'm going to lace some of the videos with this, you can see very clearly this is an injector pulse, and it happens so quickly you would never be able to pick it up with a multimeter. However, with this, it's actually giving you an awful lot of information. The sample rates on this oscilloscope go up to millionths of a second, okay, and these sort of events are happening very, very quickly. Okay, so this is on a 100 volt range, and I can change the time scale, so I can either make it a shorter time, which means that I can see more on the screen, okay? You also have a trigger, which I'll explain about oscilloscopes later, but the trigger will actually stabilize the image on the screen, okay? Anywho, I'm just going to get you a little bit moist towards the oscilloscope. I would advise not to go out and buy one straight away because these are very, very expensive. However, they are a very useful tool. Another very useful tool, it's a necessity for anybody who's looking after the vehicles, is a battery charger. I have a 12 and 24 volt one. You Land Rover guys know that you can get 24 volt Defenders. I used to have one. This is an old battery charger. It's not working as it should, and I was a bit suspect that it was actually overcharging. The vehicle here has a solar panel, to keep the battery topped up. However, it needs to be fully charged before you can put a solar panel on it. Now, when working on vehicles and you're doing electrics, you do need to, if you're going to be drawing a demand on the battery, you need to have it charged up. This one's been sitting on the drive. There's a dispute of ownership at the moment, so I've actually stopped work on it, but we'll do some tests. I removed the front bumper because the ABS modulator, which you'll see in another video, is actually hidden behind the plastic shroud, so that one needed to come off. Doesn't look very nice. It's a fairly ugly car without its cosmetics on. So the battery charger, that puts out 14.3, 14.4 on minimum charge, 12 volts. Okay, which is about what the alternator puts out anyway, which is, of course, it's respectable. Okay, you can see the reading here. It's connected to the battery. I put it on the maximum. This is fast charging. It goes up to 15.7, which is a little bit over what it really should be. I would expect actually this to be 15 volts and no more. Because the battery, it does boil, unless you have a special battery, it starts to boil the electrolytes off, which is not good. So I'll leave this on minimum. 12 volt lead acid batteries, they like to be charged up at about 10 amps. Okay, so here are my multimeters. I have two for two different reasons. This one here is an amp clamp. This one is just a very basic multimeter that I bought at eBay for 15 quid. This one cost about £250. It has an inductive amp clamp at the top there, which will read up to 400 amps, okay, which is starter motors. Okay, it is very, very basic. It's ohms, resistance, voltage, amperage, like I said, and it'll actually read temperature as well, which I've never used. Okay, now you can get these very cheaply. I paid £250 for the snap-on one, and I'll explain why in a little while. But basically, yeah, you can buy them off eBay, but you've got to be careful. You see I've highlighted it here. Jaw capacity, depending on how wide the jaw is and how much amps it will read, is something you have to be aware of. Okay, they do seem to be the cheap ones do seem to be reliable. Okay, now this jaw capacity is 26 millimeters, which is large cable, and it will read up to 500 amps, or 600 amps, which is good for starter motor cable checks. Okay, so yeah, even £5, I wouldn't rate them. You can get more expensive ones. Okay, Fluke's pretty good. You can see the prices are already going up, and these are second hand. Much depends on the budget, how much you're willing to spend, and how much electrical work you're actually going to do on your vehicle or vehicles. So this one here, inductive amp clamp, I have milliamps to 400 amps. And basically what it is, on trucks, you can have something called an earth leak, and that means the amperage will find its way back to earth somehow. And it does in cabs, or it used to. It will go up the steering column, and the shorting, which it can cause if it's a high amperage leak, would destroy the steering joints. So this is what we have to do, is to check every time we do a service to make sure that there isn't a leakage. It's actually very, very good because you don't have to put an ammeter in line. Now, basically, most tests you're going to do is with voltage. This one has a duty cycle, which is still a voltage reading, but a duty cycle is a rapid switching on and off of a current, and that would work, say, on a motor to hold it in a certain position. We'll go into that. Obviously, I'll promise this later on, but it's something that's you've got to make a choice when you're choosing a multimeter, is what you're going to use it for, and you have to understand what's in your vehicle to get the multimeter. A big expensive one, it is good if you're going to do a lot of work. A cheap one is just as good. You can see here, this one, as I said, was £15, and I actually like this one. I've checked it for accuracy. The accuracy is perfect. And yeah, just simple tests with a voltmeter will actually suffice. With the inductive amp clamp, it's clamped round the output of the alternator to battery cable, and it's reading the amperage. The good thing about the inductive amp clamp is that you do not have to put it in line, and it will read high amperage, so you just clamp it around a cable. It's as easy as that. The first thing I'm going to do, the oscilloscope is very visual. I've got an amp clamp here, an inductive amp clamp connected to the oscilloscope, and I'm also reading the battery voltage. There are either 2 or 3 readings you can read from the alternator output. Just start this up, and this will have no load on it. And basically what I'm doing here, I'll just refresh the screen and I'll show you that the oscilloscope is reading the amperage output on the green, okay, and this is the voltage. So the voltage is stable at 14.3 volts. You can see this here, bottom right hand portion of the screen, and the yellow cable, or the channel, which we'll call it. It gives you a minimum and maximum of what voltage we're achieving, and the live, which is the center one, which will give you basically an idea that the voltage is fairly stable at this point. As I say, it's a very visual tool. So with testing, I have a diagram here, courtesy of Picoscope. Basically what we're doing is we're reading one channel, and that will be DC volts, battery, positive and negative, and then the amp clamp, inductive amp clamp, on the alternator output to battery. Basically what we want to do is check the alternator output with the engine idling with no load on it, and then we want to put a load on by turning all the consumer units on and then reading to see if the voltage is stabilized and the amperage is okay. Okay, so you can see here this is live and the engine is running. Okay, so the output basically, and this is read in volts, and I will do a tutorial on reading how this amp clamp works, because it reads voltage, it converts amperage into voltage. Okay, so positive lead and negative lead respectively on positive and negative of the French style battery clamps. Okay, this is the mass airflow, and I was actually reading 16 volts out of that, and I was very curious to see whether the regulator was screwed, because the connection down here looks very corroded. So this is a test I'm doing just to see if the alternator is putting out the correct voltage and stabilizing it, as well as putting out enough amperage. Okay, so what I'll do is I'll show you this. This isn't the best setup at the moment for seeing this, because we're getting glare on the screen, but basically the engine's idling, and I can actually record this screen. Is what I'll do. Run this, do a test, and then I can put this either onto a computer, or I can look at it in the machine later to analyze the data. So what I'll do is put the heating on, the air conditioning, the lights, indicators, or should I say four-way flashers, even though some of the bulbs are missing at the moment. I'll put the wiper motor on as well, so this is actually drawing a fair few amps now. And then we'll go back and have a look and see what it's doing. Well, you can see here the alternator has responded, the amperage has peaked, it's responded to that, and you can also see a slight dip on the yellow channel trace. It's this is where it's realized that the voltage has dropped, and it's then stabilized it again. So the voltage regulator is working, and the amperage output has actually increased. So I'll bring this up to the screen so you can have a look. And yeah, basically when you understand how the screens on the oscilloscope work, it's actually really quick. So you can see that there, that I'm getting somewhere in the region of about 24 amps output. Okay, and the voltage is stable at 14.25, or the peak, it actually went up to 14.5. Minimum was a 12.84. Now 12.84 is where that dip was. So you can see we had a minimum where it went down to 12.8, and then it peaked out at 14.5, and the live is stabilized at 14.25 volts. The green voltage, you can see it's on a 5-volt scale over here, and it's actually reading 2.438 volts. Okay, now we have to do a conversion for this. So when we're looking at 1 millivolt, that'll be 100 milliamps. Okay, so when interpreting it, like say you had 5 millivolts, the measurement current would be 5 times 100, which is 500 milliamps. So if you get to use an oscilloscope, you'll realize that the readings that you're getting, like here, is not 2 amps output, it's actually 24. Okay, so what I'm going to do is I'm going to now turn all the consumer units off, and you can watch the alternator. It will change and it will react very quickly, and this is what I'm looking for. So you can see the amperage has dropped, yet the voltage output has stayed exactly the same. Well, it won't be exactly the same. If I change the time scale, then you'll probably see the dip in it. So the minimum went down to 14 volts. And then we have a drop in amperage as well. This will record it. I can later go back if I want to and check the data on the screen. However, this test can be done as well with 2 multimeters or 1 multimeter. If you just have a multimeter and an amp clamp, okay, then you're going to be doing okay. Now, I'd advise, if you got alternator problems, buying a £30 amp clamp, inductive amp clamp, will do you well, okay? So, yeah, we can go through the same tests. Basically, we've got our inductive amp clamp on the same place, which is the cable from the alternator to the starter motor, and I'm going to go through exactly the same thing. Turn the heater on, put the aircon on, which will draw some amperage, put the headlights on. Even though the headlights are not fitted, there will still be lamps there, and then put the wipers on. Okay, so that's drawing some currents, and then we can go back and check what we've got. Well, we've got 20. You see, the problem with these clamps is that they're unstable. They go low and high, and we're looking at 24 again, 23, 24 amps output from the alternator, and then we've got 14.3. So you can see that the test that you could do at home, for instance, is exactly the same without using expensive equipment. However, you're going to have a look at your screen and think, well, hang on, that'll drop to 22, 23, that'll go up to 29. Well, it's amperage, it fluctuates, and you'll get a reading that's not 100% stable, so you want to read the mean average of what amperage you're getting out of your alternator. Now, I will say the readings will be different. If your battery's fully charged and you do the test, the amperage output will be less than what you will have if you have a battery that needs charging up from the alternator. The demands will increase. This job can be done on Defenders, your Discoveries and such like. You just got to be aware that when you're dealing with electrics don't get yourself caught up in any pulleys, and make sure that if the engine's going to get hot, that the fan might start up, so make sure your cables are out of the way and not going to get caught up. I wasn't very happy with the corrosion, so I undone the nut anyway. I don't want this alternator to burn out through overcharging. However, it looks clean enough. We've tested it, so it's okay. However, what I'll do is I'll still use some grit paper and clean the terminal up, because I want to do a further test on this. And you can see there's some aluminium oxide there. And basically, you can see I disconnected before I've disconnected the alternator. So we've got, you can see the contact areas are fine. However, I'm going to put a new nut on anyway, so it looks better. Okay. It's always good to choose the right nut and bolt, and I'm using a nut with a spring washer on, because that's how I feel it should be done, so it will not shake loose in operation. Could use a nylock. The torque on these are not very tight. You're probably looking at about 25 Newton meters. You've got to be careful not to snap the post off, and always check to make sure, and do this regularly, just make sure that your alternator connections are tight. Very, very important. Okay, so here is a couple of diagnostic tricks, and this involves using a voltmeter. Yeah. Now, this is the symbol for voltmeter, and I have a black and red connectors. Okay. Now, for instance, if you had a corroded terminal here or anywhere in line, all right, then what you're going to find is that you'll have a voltage drop. The alternator will be wanting to try to keep the voltage up to a certain level, and it will keep going. Now, I've seen it where this terminal has been corroded and it's burnt the alternator out, because it's just gone past its peak and then just packed up. Yeah, and it's basically because of the resistance here Alright, so with a voltmeter, what you can do is a voltage drop test, and the voltage drop test is actually quite important. It's an industry standard, and you only need a voltmeter. Okay, so for instance, what we want to do is two things. We want to check the voltage drop between positive and positive. So if we put our connector there, and then we put our connector down here, what it's measuring is any difference. Yeah, so usually when it's positive to negative, you get like say 12 volts on between the terminals or something, and on this you do not want to really see more than that. Okay, if for instance, I'll just see if I can wipe that, if for instance you get 0.10 or even higher, then you have resistance in this circuit, corrosion somewhere, or even a partially broken cable, yeah, or bad connectors on the battery terminal. Yeah, that's one test. That's the positive side. That's the positive cable. Okay. Now, the other one you have to do. Okay. Well, this is usually good enough, but you also do an earth to earth. Yeah. So what you're doing is you're taking, like say, we'll take our multimeter lead and we'll put it to the body. That's the metal body of the alternator, which is bolted to the engine and then off to ground. And then we want to take the other lead and put it on your battery terminal here. Okay, and the same thing applies, and this is basically measuring the voltage drop on the earth. Okay, so 0.01 or 2 or something like that's fine, but if you get into higher figures, okay, 0.12 for instance, you're starting to look at a serious problem. Okay, this could either be earth connections, or it could be the alternator connected to the engine, or the engine chassis strap, something like that. Yeah, I mean, you always want to check that your terminals are good. Yeah, always. It's important. It's really, really important. Right, jumping onto the engine, I'll just show you this practical. Okay, so we have the positive to the alternator cable connector to the positive terminal of the battery, and we should be reading next to nothing. Okay, if anything at all. Any figures that go higher, obviously there is resistance, corrosion in the line somewhere. Okay, then we swap over and battery negative to body of the alternator. Okay, and I did actually clean the body up so there's no corrosion, and yeah, okay, that is reading absolutely brilliant, so there's no voltage drop there. Okay, something with multimeter leads, you've got to be careful that they don't get snagged up, so I'm just going to quickly show you what my left hand was doing. Okay, so if I'm putting the positive to the cable, okay, the alternator, that will be to the positive of the battery, and then body of the alternator to negative side of the battery. Okay, and then you check your readings and see what you've got. Another quick test while you've got your multimeter there, and you want to get it on the ohms buzzer. This will be the easiest thing to do. You can hear that. Okay. Then what you're going to do is one lead on the positive and one lead on the earth until you get a beep, and then swap the leads around, so you're going from positive terminal to the body, and this shouldn't beep. If it does, then you have a diode problem. But, however, I've got to show you this from the oscilloscope point of view. I am connected to the battery and the connector here. What I have here is AC coupling on this channel, and this will be on the lab scope. Okay, and what we want to do is to see the noise that's being leaked from the AC portion. There shouldn't be hardly any leaking into the system. If there is, then what will happen, this could, on newer vehicles, this could cause problems with the electronics, because AC voltage, okay, is interference. Now you can see here, this is a very good ripple test. The voltage is well under 1 volt. Now what we're looking at is basically keeping the AC leakage under 1 volt from peak to peak. So what we'll do is we'll do a quick check on this alternator, and what I'm getting, okay, from peak to peak is actually over 1 volt, is 1.37 of a volt, okay, and the ripple pattern doesn't look actually what I thought it would. I've got it on a 5 volt scale, and the time base is 100 milliseconds. I can change this to change the pattern, but what I'm looking at here is peak to peak, and this is from over +1 to about -1, which is 2 volts. Okay, so this alternator isn't in the best of condition. However, the system doesn't really require very sensitive instruments, even though it has got ECUs. There doesn't seem to be any electrical faults. This is not causing any issues, so we're okay here. I would, however, think that this is going to be leaking voltage back, as the battery does get flat as it stands over time. And I would recommend keeping an eye on the alternator and possibly changing it. Okay, so I just change the time base here on the bottom. So we're looking at 50 millisecond intervals, okay. And you can see what I'm actually seeing is pretty good. I'm going to save this and then analyze it later. I do need to do a little bit of research just to make sure that I'm right on this, but the leakage here doesn't look very good at all. It can get higher. If it's under 1 volt, then it is generally okay. Okay, I hope you enjoyed that. I'll try and increase your knowledge base. Even if you don't have an oscilloscope, what I'm going to do is make you understand what the components do and what sort of signals they put out. So, until the next video.